Okay, so I have a student asking me about this question for acid-base equilibrium from Nanyang JC. So you have solution B found to be sodium hydrogen carbonate. Using the data below, explain why solution B is basic rather than acidic. So if you look at the two equilibrium that they give to you, right, Ka1 and Ka2, they're referring to the acid because Ka is for acid, right? So showing the dissociation for the first H plus to form HCO3 minus, and then the second dissociation HCO3 minus to become CO3 2 minus. Okay, so the question is asking why is this solution, right, basic rather than acidic. Hydrogen carbonate, this ion, which is present here and here, for the first equilibrium, it is acting as a base. So we cannot just take the Ka value. We need to change this Ka value to Kb. All right. And then for the second equilibrium, it is acting as an acid. So we can just take the Ka2 value and compare. So if you look at the work solution, right, hydrogen carbonate can act either as a base or as an acid. So in the first equation, it is acting as a base. So you need to change the Ka to Kb. All right. So you get 2.22 times 10 to the power of minus 8. And then for the second equilibrium, right, it was acting as an acid. So we can just take the Ka2 directly from the question. So when you compare the two Ka and Kb value, right, you realize that Kb is greater than Ka. So hydrogen carbonate is deemed to be a stronger base than an acid. It means that it will actually dissolve in water to produce OH minus rather than the other way around to dissociate and give you CO3 2 minus. Okay, so this is how you will hydrolyze hydrogen carbonate plus water to give you carbonic acid and OH minus, which makes the solution basic.